Well, hi, good morning. Thank you so much for joining me in my shop here. Today is September 12th, another beautiful day outside. It's going to be sunny all day again. Fantastic. So, yesterday I kind of looked this radio over for the first time. I made a number of observations here which aren't quite adding up, which just leaves me with a few question marks. The biggest one is this cable, which at a glance you would think this is the original cable going in. You can see it's got 6 wires here. I've kind of paired them off, but there's six wires in this cable. The schematic will show you that a cable like this should only have 4 wires in it. At this end of the cable, as far as I can see, there's only 4 wires coming out. 2 of them have been cut back, I imagine somewhere in here. Or I've missed the 2. There's 2 more coming out. There's 6 wires and I didn't see them, which I don't think is the case. So you got to kind of wonder why a 6-wire cable, and why did they bare off all the wires? All 6 of them have been bared off by somebody previous to me. There's also a bit of a defect in this cable in some of the wires right up in here, which we'll have to deal with at some point to make it a little bit safer or better. So that's a bit of a question. What's going on there with 6 wires, 4 wires? What's up? Another thing is, well, obviously the knob is right off the front of the radio. That's a mechanical issue I'll be dealing with over a period of time. Hopefully that will kind of just sort itself out with a bit of penetrating oil and some mechanical effort there. The dial is sitting right here. The next thing is exactly which vintage radio is this? What would be exactly the correct schematic? Now, I think this is an early run radio. This knob suggests it's early, but other parts suggest it's later. So it's a bit of a confusion about just when this might have been built. This radio has wax capacitors in it. The other HRO radio that I had in here a couple of weeks ago or a week ago had molded capacitors in all these positions. As anybody would tell you, these wax capacitors generally don't last 100 years. Well, in this case it would be, what, 80 years or something like that. Another issue is, well, how is the output done with this radio? Now, some of the early radios, if you plugged your headphones in here, they had to be 7,000-8,000 ohm headphones, and you're actually running a plate current from the output tube through it. Now, is that really true? I probably got that a little bit wrong. When I studied the schematic for an HRO radio, it shows this connector getting its feed from the tube ahead of the output tube. So the output tube is here, and offhand I think it's this tube, which is the detector tube and produces the first audio amplifier here, building up enough signal to drive the output tube. But this tube's output is tapped off and fed here, but again, it's the plate circuit, and so that would potentially have, a good word, potentially have B plus right on this connector on your headphones. Doesn't sound like the best idea to me. We can look at that a little closer, but I think that might be the case. So in terms of powering this guy up, I love powering up these old radios as soon as I dare, and this one, it looks to be in good enough condition to try it, although we don't know what the result might be. I haven't seen anything here other than a little bit of confusion on the wires and two unconnected wires hanging out here for reasons unknown. Could I go a distance towards powering this up and maybe even get it operating? And I think the answer is yes. As long as I take a careful, stepwise approach to this and not just try to plug the whole thing in and fire it all on at once. If there's something wrong with it, I should be able to detect it without running the risk of powering it right up. And what would be the risk of powering it right up? Not too much, I don't think, really. Maybe it doesn't operate. Maybe there's a short circuit in it, and the risk in that case would be a risk to the power supply that's driving the short circuit. I think if it's done carefully, there's virtually no risk. I suppose if we studied the schematic long enough, we might find a situation where a shorted capacitor can draw a heavy current through a coil and burn the coil out. Now, that would be unfortunate. Burning out a coil is unfortunate, but not terribly likely either. So can we operate this radio with a knob off? Sure. In fact, I'm going to try to turn this again. Oh my gosh. Sometimes I can't get my tools out of there. So again, I'm going to do my best to not knurl this up while I try to give it a turn. I put a little bit of oil on it, but not much. And I would imagine it's... I think it's moving. But I just want to move this a little bit. So the problem is you'd never see the movement in these capacitors with just a little tiny movement out here. So I can see the shaft turning here. And it's turning more and more as I go. Okay, we're going to leave it like that. I didn't knurl that up. I'm going to throw a little more WD-40 on it here. I can see some. It's still there from yesterday. There we are. And I'm going to turn this just a little more again. This is just to help the solvent work its way in. I'm assuming most of the back pressure I'm feeling in the tool is because of this sleeve and the shaft inside it. It's nice. Let's see if we can see these. Okay, I still don't see any movement in here at all. But it shouldn't be too surprising. I'm barely moving this knob, and the ratio from here to there, what did I read? 50 to 1, was it 50? I'm not sure how you compare a number of revolutions to travel of a capacitor. Anyway, you get a number like 50 to 1. Now, so a couple of things I can do here. One, I can bring in the heater power, and 6 volts to drive the heaters. I could hook that up and see what happens, but nothing much is going to happen. Even if the set works or doesn't work, it's not going to, like if there's a problem in the heater string, which isn't very likely, how would I even know? I think what's a lot more interesting is to hook up the B plus on this radio with no heat in the tubes at all. I just run the B plus voltage up, observe the current being drawn by the set, which should be very low, very, very low. And if there's a short in the high voltage circuit, we'll start seeing that just by doing this test. And if I get enough B plus on it, and it would only take 50 volts, let's say, I can then examine the voltage here and find out if 50 volts is showing up there. That'll tell me a little bit about the dangers of utilizing this. I want to connect the output of this into my system here in my shop that you're listening to me on, but I don't want to hook 50 volts up or 200 volts up to it. I think that might be pretty painful for my equipment. So if we can get a distance through those tests, then I'll be more encouraged to go ahead and actually power the whole setup today and see what we get. I guess the other issue too is not only is there DC voltage here, but how do I connect this to my audio system? If this is a high voltage thing and it's looking for 7,000 ohms in a pair of headphones, that sounds to me like quite a bit of voltage, signal voltage, and that'd be far too much for my system too. So I got to think these things through a little bit. I think we'll start with the DC test right off the bat, and we'll see what happens with that. Great. One of the things I wanted to do was positively prove to myself that this is a 6 volt radio. I'm pretty sure it is. So I've pulled out the output tube to look at it and see what its number is, and its number is missing, but it looks like a 2 on the end here, like a 42. Isn't it supposed to be a 45? 42, something with a 2 on the end. Let's look at the schematic here. The output tube of 42. Okay, somehow I got a 45 in my head. 42. So 42 is a 6 volt tube. I'm pretty sure. Yeah, because these are all 6 volt tubes here. Okay, just wanted to make positive certainty of that. Now, here's the phono plug, and I plugged a. This is the jack. I've plugged a plug into the jack with the ends available for testing. So this looks pretty complicated in here. Let's see, the signal's coming through. Oh, coming through a capacitor. So I wouldn't expect any B plus to appear on this, unless this capacitor is leaking, which is possible. And of course, what am I looking at? I'm looking at a schematic for a much later version of the radio than what I've got. So these particular things could be different, especially this. So can I rely on this? No. No, I've got to do a test, and we'll see what happens here. Okay, so I have a regular jack plugged into the radio. I can test. I have the radio connected here. I don't have my. For some reason, I didn't turn my own monitor on to see what's on the screen here. So we're going to be using this power supply, which I can put on standby here and let it warm up a bit. There we are. Now I can see what you see, and I've connected the cable to the B plus terminals here, and the B plus level is set to 0. I have a meter connected right where the other end of this cable is. So this cable ends in the radio, the meter is connected there, so we can see what's on the end of the cable. And then I have this meter ready to go, which you can't see. This meter here. Oh, terrible lighting in here today. Who's doing that? Don't exactly know why this is. Oh, you know why this is so washed out? Because of this black surface here. If I put a white surface there, you'll be able to read my meter. Watch. Yeah, now you can read the meter. Big black thing in view of the camera. Okay. We can change this a little bit, I think. Maybe. Video issues. Was not expecting that to happen. Okay, we can get along like this, I think. So we're reading the voltage arriving at the radio, and then the voltage that's on the end of the test probe as I poke around. Especially, I'm going to be poking on this guy right here. That's the ground, and that's where I want to find out, is there high voltage there or not? Now at the same time, I'm applying high voltage to this radio for the first time, so there's a good chance that there's something wrong in the radio, and I won't even be able to build up the voltage. While we're doing that, turning up the voltage, literally. Let me put this here. Oh, I can't get everything into the view here, because we want to keep an eye on this meter in particular. That one shows the current flow, and as you raise the voltage, a certain amount of current is going to flow into the radio, and if it's too much, I want to know how much is too much. Under this test, with the tubes not heated, not operating, it should not be much at all. It should be a tiny amount. I would take a guess, 5 to 10 milliamps, no more than that. There's a lot of capacitors in here that are going to be stressed by this test, and some of them are going to be leaky. There'll be some additional amount of current. But again, that would be, a tiny amount of current. This could even be 0. But as I crank up the voltage, there'll be charges flowing into these capacitors in the radio, and those charges will, the charge is current flow. So you see this meter pop up and go down, pop up and go down. How high will it pop up? Depends how fast I turn this control. Not very high. So if we manage to get the to get this to work. Let me put this. Oh my gosh, I got so much lighting trouble here with this big black radio in here. If this stays low enough, And I can get this up to say 150 volts, somewhere in that range. That would be 150 on this meter you can't see anymore down here. Then what? Then we'll be able to proceed with the check for high voltage on the output here. That's a plan. Okay, you can see pretty much everything, but you can't see anything because of the way things are lit. Why is it like this in my shop today? What if I just cut this light off here completely? Wow, that's really not going to do the trick out of it. Made this light come on. Smart meter. It's just terrible. Let me, if I look downwards at it, it might just be a little bit better. Oh, I'm just trying to get these pointers to show up on the live. What if we blast the radio with light? Nope. Now, sort of. I apologize for doing this, but I do make these videos essentially live, including this kind of nonsense. Well, you can kind of see the pointers. That's a terrible arrangement. Probably if I step in front of it, it's all going to change. Yeah, it's going to change a bit. Well, I can see it all quite clearly, so I'll just have to report the results here. In the end, we're going to be focused on this meter anyway. Maybe if I just do this and try to get right above the, yeah, now there we are. Okay, now you can see the action. We're all set here. As long as I don't step on the wrong wire. So I'm going to flip this to on. And now we're going to watch this meter go up as I turn this dial, and watch this meter pop up. This is and the set is, there is no on off on the set. There is a B plus switch. Okay, the B plus switch is in a position, I don't know what. Let's give it a go. We'll see what happens here. Okay, so I can see this meter coming up. Current meter is just moving the width of the needle, which is excellent. The other voltmeter down below is showing 30 volts. Okay, so we got 30 volts, and this one is showing, you know, close to 50. It's not accurate. Not accurate meters. We'll go up higher. Okay, so on the meter down below, we're getting close to 100 volts. Let's stop at 100. There's 100 volts. Now, there's zero current leaking. You know, this is not exactly a very, very sensitive meter there, but nothing of any significance is happening. That could be the B plus switch is off. So the switch I'm talking about is this one down here. This switch is intended to cut the B plus off from going through the radio while you switch the coils. This is the idea. Make things a little safer during that operation. So I'm going to lay off the voltage here. Maybe nothing went into the radio. It was a small current flow, so there must have been something going in the radio. I'm going to throw a switch. We're going to crank this up again. Watching that current very carefully. Okay, this time we're getting up around 100, and this meter has not moved at all. We're at 110 volts, so I'm pretty sure the switch is open now. I'm going to put this down to about there. Now I'm going to flip the switch, and we're going to watch for the current to jump. Oh, you see it jump there just a wee bit? That was the charge going into the capacitors. Next to nothing. And another test we're going to do, we're going to watch this meter. I'm going to turn off the B plus. We get 71.8, and when I turn on the B plus, 71.7. I mean, it didn't really change at all. So this is a very good indication that you can actually operate this radio. What is going on here? What's going on with this meter here? So I just looked over, and I think I saw this meter kind of bouncing around. Now it could be where it is because I've got the radio on its side. Let me turn off the B plus. Oh, I was not expecting that. But you know, that might make some sense because the B plus, like one of the earliest things that happens in the radio with the B plus, is it's fed to this meter. I think it's a current flow through one of the tubes that it's really monitoring. I don't understand. This switch is pushed in. Shouldn't this just be nothing? Watch out for that. It could have high voltage on it. So we don't want to, well, the meter works. We don't want to burn it out. Wow, lucky. Because maybe in other circumstances, if I wasn't watching and I hadn't seen this, I might pin this meter and burn it out and never realize it was me who did the damage to it. Oh, okay, so I'd like to pull this out and see what happens, but maybe what happens is the meter burns out, so I don't want to pull this out. It seems to me pulling it out would be turning it on and pushing it in would be turning it off. I can back down the B plus. Look at that, it's like a B plus meter. Okay, it's down to nothing. Give it a moment. I'll pull the switch out and we'll put it back up very carefully now because we don't know what's going to happen. So this seems to have turned off the meter. Okay, back up to 100 volts and the meter is not moving. I'm going to leave it like this. Yeah, and I don't have to worry about it. We've got about, according to the ammeter on my power supply, 2 to 3 milliamps running in this radio right now. Okay, some of these other settings, this should be off. You can see this dial's not, notice this when looking underneath, the dial's not in the right, oh, maybe it is in the right position. Yeah, it's just a lot of excess play in this control, just does nothing out here. Okay, okay. I thought I found something wrong with it before, but no. Audio gain, well, oh my gosh. Wow, so nobody's turned the volume on this for many, many, many years. I can hardly turn this thing. Wow, let's just put it down around 30 here. Wow, that's really that's a sign that this guy's been sitting for a long time. Even I hadn't turned that control till now. Let's see the phasing control here. Okay, this should be set. Well, we'll set it in the middle. It won't really matter at all for the test I'm doing. And the RF gain, again, this doesn't really matter, but I'm just turning it. Well, it moves. Okay, so what we want to do now, we've got 120 volts on the radio. There you can see the meter there. Still, current flow is still at the same point, low. So we're going to grab this voltmeter. This guy is set to 150 volts full scale. The first thing we're going to do is measure this voltage again. And the second thing we're going to do is aim the camera. I want to verify these meters read the same. So I can do that up here. So that reads 100 on this meter. About 115 is what it says. 116. So a little low compared to here. On the other end of a clip lead. Could that have been the difference? Careful, man. That's the same thing. 100 and 116. Okay. What's on here? This is what we're excited about. So that's the ground. Here we go. Anybody home? He's all there. 120 volts. Okay, so that answers that question. Sort of. I'd have to, well, you know what that suggests? The schematic we're looking at is not for this particular model or version of this radio. So in that version that we looked at, the schematic for, they may have made arrangements to reduce the B plus or get rid of the B plus on the front of the radio, because how dangerous is that? That's really dangerous. And we also saw an output transformer on that schematic. It does not exist in this radio. So I think really we're looking for a high impedance connection here of 7,000 ohms And then somehow, if we're going to run the radio, I've got to tap the audio off of here. So now it's had 120 volts on it for, I don't know, how long has it been, 10 minutes? And the amount of current flowing is still just 2 milliamps. That's very encouraging. Any other buttons to flip here? I can flip this one. I could flip one of these buttons and flip in a short circuit or something if I'm not, you know, could be. And that's about it, really. I don't know. Should I do the test with this in or take this out? Just leave it as is. Leave it as is. What is the test? What the next test is applying power to the tubes and seeing how that goes. Okay, let me set up for that and drink a little bit of coffee too. We're gonna have this thing going soon. Okay, I think I'm ready for the next test, which is firing up the heaters. So what I've done is I've attached the wires from the cable to the heater. Is that, I don't know if you can see that. It's a 6.3 volts right here. Good for 4 amps. This thing won't draw 4 amps unless there's a problem. Knowing that the tubes are heating up, well, there's only really one good way to do it, and that's to look at them. So I'm going to be shutting off the lights, and then we'll be looking at this tube to see if it's lighting up or not. At the same time, I've got this voltmeter set now to, what is it, 60 volts AC. So it's set to AC, and it's going to read the voltage at the other end of the cable to see that the power is getting to the radio. There is no on-off switch for this. As soon as I flip this guy, oh my gosh, it may be on. Oh, no, it's off. As soon as I flip this on to standby, oddly enough, it will supply power down here. So the heaters will come on as soon as I do that. If there's a problem, there's not a lot here I can do to stop a bad event from taking place. It would probably take place in my power supply. There is no way for me to read the to read this power other than what I'm doing. Well, I could put a current meter in there. I'm not going to do that because I have some faith that this is going to go well, and I'm not too worried about this. But I can't do it kind of slowly. It's like on and let's see what happens. That's how it's going to go. This meter over here is doing nothing, just having a break. And we want to rotate this radio around like this so we can get a look. And I'm going to switch off some lights here. You know, I'm going to leave this one on. I'm going to switch off the big overhead light here. Okay, we still got a little bit of light to operate by. Okay, last chance to realize I'm doing something wrong. So there's still a couple wires hanging out in the back here. We don't know where they're going or what they're doing. But, okay, if I flip my power supply to standby, there'll be no DC voltage, and I have this turned down anyway, but there won't be any DC voltage coming over. So quick response would be, I look over and this meter says 1 volt or 2 volts. That would indicate something bad is happening. But this guy comes up and says 6 volts or somewhere in that range, 5.9, 6.2, then we're cooking with gas. And then we're going to look at this tube up here in the dark. It should light up fairly quickly. Okay, so I'm going to have my eyes on this meter. Here we go. Oh, don't. This meter has an internal light that seems to like to come on kind of randomly. Here we go. 4, 5, good. So notice can you see the big bright red light there? I forgot about this. Very good. Now, is the tube heating up? Yes, the tube is heating up. I can see it. Maybe you can kind of see there's some kind of light down in here. You might think it's this. Can you see there's just a little bit of light in there? Okay, so this is settled down at 5.7. There's bound to be some kind of a, come on camera, you can do it. No, I can't. There we are. So that's okay. There's a voltage drop going on apparently in the cable. A little less instead of a little more is good. All I got to do now is just flip that B plus switch on, and this radio is ready to operate. But except for one thing, they don't have an antenna on it. Let me turn this off. They don't have an antenna on it, and I need to drink some coffee before this event. Because the last HRO radio I did this with, it worked really well. We can't tune this one. We can't hear this one. wait a minute. We can't tune it, and we can't hear it. Okay, I got some more things to work on here. Okay, while I'm making the last connection, let me think this thing through. So the last connection is an antenna. Believe it or not, I'm going to put an antenna on it. How's that for optimism? Okay, and the antenna connection's up here. Hey, which one's ground? Which is which? Well, you can see the ground. You can see the wire going to the ground. So I'm going to put this up. This is going to the outdoor antenna I'm using is a mini whip antenna. A powered antenna, if you like. It has an amplifier in it. It's very good. Works very good. You can see I have the scope running here, and that's because we're not going to listen to this first. I'm going to hook the scope up to it, and we'll see what's coming out here. And what's going on here? I've put in a load resistor. This is a 8,000 something. It's an 8,000 ohm resistor. 86, I'm not sure. I think the radio is looking for 7,000 ohms here. This will do fine. I put a high wattage one in here because that's what I got in my hand, a high wattage one. And then I have a capacitor I just soldered to the hot side of this deal and hanging open here. And I have my scope lead ready to clip and see what's there. Why wouldn't I clip it right now? I don't know. There's no reason. I'll clip it on here. Okay, scope. We'll set this way up, and it's set to AC, so it won't see the DC that's here at first, because with 5 per division, and I'm going to crank this up to like say 100 volts, so that's going to go right off the scale. I wonder if I should be using a times 10 lead here. Maybe I should. Let's do that. So this is just a straight wire lead. And use a proper test lead here. Oop, a whole bunch of stuff just hit the floor. Just put the ground on the ground part of the connector, and then we'll set this to the times 10 setting. Means you multiply the reading by 10. So now it's 50 volts per division. And so that should stay on the screen. We're not going to hear anything at first, but if we might be able to tell from what we see here what's happening with the radio. We might. What I'm really interested in is just, how big a signal is here. How much voltage am I dealing with before I hook it up to an audio system? Can't tune the radio. CW oscillator is off. Audio gain set to 3. Let's just set it down a little lower. And RF gain we're going to set it to about 8. B plus switch is closed. Meter's turned off, I believe. So I think we're ready to go. So we still have this meter connected to the heater voltages, so we might as well just turn it on and observe. And the B plus we'll have to just roughly, well, I could read it. I could read it if I wanted to. I could. Why don't we do that? Because I think it's a good thing. During this, it's probably a really good idea to keep an eye on it. So we'll hook this meter up to the B plus. DC, and on the red wire here. You know what, might be better to go right up here rather than go inside the radio. Okay. So this guy's set to 150, so we expect him to come up about straight, or a little further over, getting around 100, 120 up in this area on the meter. Should be, I think what I've read is this radio will operate with as low as 130 volts or something like that. So we'll probably have to push this up to 150 to get something, but we won't know what we're getting because we're just going to see it on the screen. So turn heaters on, give it a moment, turn the B plus on, crank it up, watching all these meters all at once and the scope. Got to watch everything everywhere all at once. That's what we have to do here. Okay, what kind of panics can happen? Smoke come out of the radio? What do I do if there's a panic? The only thing I can do is reach. I got to reach up here and turn that guy off. That's my only option. There's no switches here to turn off, nothing over here, just that one control on the power supply. Okay, I think I'm ready. So step one is turn on the heaters. Step one, heaters on. How come we're not seeing? Oh, I got this on DC. Okay, here we are. Okay, so could be there's dead tubes in here. Who knows? We don't know anything. We know nothing. Okay, nothing funny happening on the scope. What if we make it really sensitive? Nothing at all on there. Okay, so I'm going to raise the B plus now. I'm probably going to step in front of that meter, am I? If I hold my shirt back, I'll be okay. Okay. A little nervous. Should be. Okay, here we go. Okay, now the B plus voltage is 0. Nothing should happen. Nothing is happening. Perfect. Here we go. We're going to raise this up. I'm going to watch the current now because the tubes are hot. They're going to draw current. So I'm watching the current meter. Did I just hear something? Okay, so the voltage is about 60 volts, and there's current flowing now about, I think when the set is running full, it draws about 70 milliamps. So we got a long ways to go here. I don't know if you can see the meter. You can't see the meter because of the lighting fiasco. So you just have to trust me here. Going up a little higher. Still nothing on the scope. Going up higher. Higher, higher, higher. So we got 25 milliamps flowing. We're at 120 volts. We still have our heater action. We see nothing here. Okay, no voltage at all. Now I've got this set on AC, so I'm going to flip it over to DC, and I think we'll see it jump. Nothing happened. Nothing at all happened. That's not what I'm looking for. I've got the right button pushed here. Just to double check. Yes, absolutely. I'm surprised. No DC response at all. Why? Why is that? Now this is reading up at the supply. I'm going to change this meter, and we're going to look right in the radio here. So first at the end of the red wire. Okay, it's there. And now any tube, anywhere. Any tube, anywhere. Plate, just guessing. We're just looking. I'm just going to go around the terminals on one of these tubes. and try to stay away from the heater terminals if I can. Can I even recognize them? I don't think so. Any voltage? Yeah. Yeah, I like that. I hit the plate right off the bat. So we know voltage is getting right into the radio. So now what's possible is we just don't have enough audio turned up, and we don't have this sensitive enough to see what's happening. Let's start here. We're looking for kind of like a noisy signal. This is now maximum sensitivity here, and we will turn this guy up, and I don't see a thing happening on there. This is still set to DC. We're not going anywhere. Well, what am I talking about? That's good, Jim. You've got a capacitor here. That's okay. I'll be okay. So let's do this. We'll set this to ×1. We'll see what we get. Oh, there's a little shaky there. Little tiny shaky. Now this is a tiny voltage. Let's see if we can make a change by changing either the audio gain or the RF gain down below. Here, RF gain first. Oh, there's something happening, only I'm turning it down. Let's go up. Maybe it's noisy control. So this didn't change. Here, it remained kind of the same. So I've got the RF gain up full. We will try audio here. Pretty close to touching this. I didn't think about that, but I don't want to touch that guy. My hand. Oh, now that's good. Can you see what's happening on the scope? No, you cannot. So I'm going to fix that right now. I use my super advanced technique here, using a stick and the other camera and a clip. I'm just going to whip this on here. It may not be level. I'm going to spend too much time leveling it just so you can see it. Okay, I'm going to flip that onto the screen. Here we are. Okay, what was I doing? I was turning the volume up. So we're going to turn the volume up. There, you see that jump? So that's going to be dirt in the volume control or something of that sort. Okay, I'm turning it way up now. So it's starting to look like I'm going to stop turning it. The same thing. Nothing. RF gain again. Doesn't seem to do a thing. So this voltage is really like I've got this set to the most sensitive setting it can go on, and I've got the probe on the ×1. So let me just, yeah, that's ×10. That's ×1. So there is some little tiny signal there. Why can't we listen to it? I don't know. Let's turn on, we're fooling around here. I'm going to turn on the BFO oscillator here. It's on. And nothing happening. AVC switch. Oh, did you see that? That was interesting. Again, there's a very low signal. That's some kind of tone. It's probably the BFO tone going. I'm not exactly sure why it's going. That's off. So BFO off. So we got some audio out of it, of some sort. Let's make that happen again. Okay, and I'm going to change the audio gain and just see if it's... Okay, so I'm turning the rate right down to, it's at 2 now, so it's not going down. I don't know exactly what we're seeing there. Watch your finger, Jim. There's a high voltage right there. Well, that's interesting. Just so you know what I was up to. So I'm moving this control here. Let's see if I just... Oh, danger! Okay, so that's an antenna clip that came off. No danger. I was prepared to reach for that power thing. Yeah, isn't that staying on? Stay on now. Stay on there. Okay. So why wouldn't we try listening to this? There's next to no signal there. We'll put it through the amplifier that you're listening to, that my microphones are running through, and we'll see what we get. Okay, I'm going to drink some coffee before I do this deal. Okay, if there's going to be some surprises, I like to get it on camera. I don't like things that happen in my shop off camera. I mean, the whole idea is for you to experience this whole thing the same way I'm experiencing it. Okay, so what I've done is I've got a lead going into my audio control over here. This is the audio control. These two controls, if I turn them up, will hear the radio through this cable I'm holding. Right now they're down. These are my microphones over here, just so you know. And you couldn't hear the terrible things I just said. No, I didn't say anything terrible. But so, just so you know what I'm up to. And we're going to, you can see I've connected another cable here. And it has a plug like that. I just plug this in here, and oh boy, we're listening to this radio if I turn those volumes up. But I'm not listening to the audio you're listening to until I put these headphones on. Put them on here. It's got wires everywhere in my shop. Okay, wired headphones. Now I'm going to apologize in advance for losing control of the volume. This is probably what's going to happen during this affair. So the volume is down. I am going to gamble now. It's not much of a gamble because just double checking. This is on DC and there's no DC voltage there. Let me pop it on ground. Yeah, see? No DC voltage. Nothing to worry about, Jim. Okay, we're going to plug this guy in. You shouldn't hear anything. Good, we didn't hear anything. That's good. I'm going to strain relief this over here so I can't yank it on the radio itself. Okay. I just got to turn up the volume controls over here and we'll hear it. So they're all the way up. We don't hear a thing. It's because I've got it plugged into the line input over here because I was worried about the level. So I'm now going to switch the line input to microphone input, minus 20 dB, so there's still a down on it. What do we hear? Well, we hear something. Kind of only out of one ear. Oh, yeah, only out of one ear. So put it in the middle here. Right, it's only mono, Jim. So we're listening to the radio now. And not hearing much. Faint hum. I'll just turn this down a little bit because I'm worried that all of a sudden, wah! I mean, that could happen. So if you're wearing headphones like me, get ready because at any moment, wah! It's just come on full tilt. What do we do now? So we double check everything. So B plus voltage is, oh, I'm going to look myself here. Just 120 volts. That's just a touch low for this radio. We should probably push it up a little higher. I think the normal is like 250 or something, so we're still at the low end. We know this thing did something. Let's hear it. Okay, volume's down, volume down. Switch this on. Get the effect. Okay, I'm turning up the volume here. No effect. Oh, there it is. I see it on the scope. Well, we don't hear it. Why don't we hear it? Either this frequency has nothing to do with audio and it's way high and we can't hear that, or it's not making it through the radio and coming out the speaker. Or this just isn't working right, or maybe I don't even have enough B plus to make the oscillator oscillate. This is the AVC switch here. Either way, it's pretty much the same thing at this point for doing this testing. Okay, RF gain is up at 10. Okay, put the volume up. Don't hear any crackling. Don't hear any noise whatsoever. That's not a good sign. You hope to hear something. Okay, down, and Oh, that's good. Thank you for that. Okay. Just what I need. Fire alarm going off in the middle of this. I'm going to turn up the audio gain, see what we get. Well, it certainly is making a little bit of noise. I'm going to turn up the B plus now and see if that brings the radio to life. So this is up at 8. This is up at 6. Not feeling so hopeful here. Let's raise the B plus higher. The radio's only drawing 25 milliamps when it's supposed to draw 75, so it's way low. So I'm going to again, I'm going to step in front of the. You can't see the meter, right? I'm going to step in front of the meter, turn up the voltage. We'll just listen to what happens. Audio's up. Audio's up. Everything's ready. Okay, here we go. Okay, so we're at 120 volts. We change scales here. 120. Here we go. 150. Pushing 200. That's 200 volts. Okay, 200 volts has got to be enough to make the radio work. What do we hear? A little wee bit of static. Not much else. Okay. Get the impression it's not working. What else can I do here? So I can fiddle around with the RF gain again. We still hear nothing. That's coming through the microphones, I'm pretty sure. Yeah, you're just hearing the sounds like a wire wound. It is. It's a great big wire wound resistor in there. What am I missing? Am I missing anything? Have I not thought of something? Yes, probably. That's probably the case. We got no clue where this thing is tuned, really. Well, oh, jeez. What was that? What was that pop? What could that have been? I started rotating this, and there was a pop. Scared the bejesus out of me. I don't know. Everything seems fine. Don't know what the pop was. What was the pop? We're going to connect and disconnect the antenna and see if there's any static that comes through in the radio. And I say no. So, ooh, what was that again? I didn't like that. Pop without explanation. So, antenna is having no effect. Stay there. Is there anything more we can do with this at this point? Is there any reason to believe this is the functional way to do this? Not particularly. just using my imagination to come up with this. Well, although this worked in the last radio, but it had an output here from an output transformer, and it was easy to make a connection. Can't think of anything. Okay, so we're going to shut this mill down here. First the B plus going to go. You can hear the radio get a little quieter, and then we'll flip off the heaters. Now that funny sound, that may even come from the power supply I was using. Let me take off my headphones before I trip on the wire. So everything's off. Now we want to see, are these tubes, do they all warm up? Warm. 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 Oh, that's not a tube. Yep. Yep. And then what about this glass one? Oh yeah. Oh yeah. Well, there isn't a dead tube in here, like an open heater type tube. That's as far as we can get today. Yeah. That's not the most satisfactory result, but we were able to power the guy up, put on the currents and the voltages, and nothing terrible happened to it, which means I can continue testing this, do signal tracing, fool around with it quite a bit, which is what I would intend on doing before making any changes to it. And what changes would those be? Replacing capacitors. So we can start doing some fun stuff with it tomorrow. That's it for today, though. I'm done. Thanks a lot for watching, and tomorrow, as I say, we'll just continue trying to get this guy to work, or find out why it doesn't work. Maybe that's a better way of putting it. See ya.